Put it up on the television. What numbers did we do?
2 through 30.
2 through 30 evens. Yep. Turn the page, grab the thing. Okay. This lesson is not actually hard. I know it seems that way. You just gotta figure out how the pieces work. That's our goal. So I should do this in order. Yeah.
I'm pretty sure I'm failing classes.
You're pretty sure you're failing classes.
Including this one because I could not understand this last lesson at all whatsoever.
So you what?
I'm pretty sure I'm failing.
You're pretty sure yeah, I got that part. I repeated that part. But I didn't hear the other. You didn't understand this lesson at all, and so what?
I'm probably going to be going to the tutoring on Saturday.
The tutoring on Saturday. What tutoring on Saturday?
I have no idea. My mother just told me that I was, so.
I don't know what you're talking about. I don't do tutoring on Saturday. So maybe you're going with somebody else or something? I don't know.
Maybe. I was just told to tell you that, I guess, so. Yeah.
Okay. Well, you may need to double check on it because I don't do tutoring on Saturdays. That's not a thing that I do. So if your mom is expecting me to be somewhere, then that's not going to happen. So I don't know.
No, I don't know. That's all I was told, so.
Lap. You didn't understand this lesson. What about it did you not understand?
The part where it has to do with the functions.
The part where it has to do with the functions. What do you mean?
Specifically on the piecewise defined functions.
Okay, what about it?
I just could not understand how to do it whatsoever. I've watched multiple videos, your video multiple times. Couldn't understand it at all whatsoever.
Do you understand how to graph lines like that aren't piecewise? Or are we struggling with that part?
I'm struggling with everything about it.
Okay. Okay, so there is number 2. And there's number 4. And there's number 6. And there's number 8. There is number 10. And number 12. And number 14. And number 16 and 18. And there's number 20. And 22.
first lessons we hit in Algebra 2 that if our Algebra 1 is solid, we may be like, okay, this is scary, what's happening? So where do we want to start? What questions do we have?
Can we do 4?
We could do 4. We could certainly do 4. Yeah, I'll flip that around, but it dawns on me that I think 4 is one of the ones that has a picture and then we're supposed to write it. Is that right?
Yeah.
So I actually still need it to be the other way around. Alright. Let me take a picture of somebody else's number 4 because y'all's is bigger. Okay. Okay. So we're supposed to look at this picture and we're supposed to write a take this sideways, that's fine. We'll deal with a tiny space. We got this. We're supposed to write a piecewise function given that picture, right? So we need to figure out first where the pieces are, right? So where are the chunks?
X is less than -2, or no, greater than -2. Alright, less than. Alright.
You're right, we get less than -2, yeah. So the first one is right here, right? This is our first chunk. So x is less than -2, not equal to, right?
Yeah.
Because it's open circle. So that's our first chunk. Where's our next chunk?
Plus x is greater than or equal to -2 or and less than 3.
Less than 3. Yeah.
Or less than or equal to.
So x is between, it's equal to on both sides, right? X is between -2 and +3, right? Easy peasy. And then what is our final chunk?
X is greater than 3.
X is greater than 3. Right? Okay, so those are our chunks. That's a good place to start. Now we need to figure out what they are in each one of the chunks. One of them is easy on this one. Because one of them is a constant function. Which one of them is a constant function?
The first one.
This first one?
The x is
This one right here.
yeah.
That was not a constant function.
Oh no, it's the line one.
Yeah, it's this guy right here. In the middle, x is always equal to, not x, y is always equal to what? -2, 3, right? -3. So it's always -3 on the middle chunk. So that was easy peasy. They had to do it that way. They had to give the middle chunk be the easy one. take two points and put in the slope formula, or you can just kind of count, right? Either way, right? And when you count, you go from a cross to a cross. What do I mean by a cross to a cross? And I've kind of labeled some stuff on there to help us out.
When it hits like the whole numbers.
Yeah, where it goes on the grid. If you can see it go on the grid, that's where we're counting from, right? So we're counting like from here to here, right? So to get from this one to this one, we do rise over run, right? So how many do we have to go up to get from here to this guy?
One.
No, these lines aren't going by ones.
Two.
Two. So we're gonna go up two, and then we gotta go over how many? Two. And then 2 over 2 reduces to
One.
1. So the M on this chunk is 1, which is handy, right? That's because that way we know that this is just going to keep on floating right up here if this was to continue, right? It would hit right here. So what is the y-intercept of that chunk?
4.
4. So for this one, it will be 1x, which is just x, right? Plus 4. Does that make sense? Anybody confused right now on what we've got so far on the board? I will take the sun silence as you're tracking with me. Because if you're not, we gotta like send up flares. We can find the slope of this one. So how are we gonna find the slope of this one? We're gonna change colors. We can have some clarity. Find the slope of this one. Same thing, we're gonna go from across to across. So there's a cross right there, and there's one right. That's harder to find. Looks like it crosses in the middle. Looks like that's in the middle. That's in the middle. I don't see an exact cross unless it's this one. Where does it look like there's a cross to you guys? Y'all see one?
I just used the first one.
For that one, I used the point that was in between the
Yeah.
crosses.
This one?
Yeah.
Okay. So this one, which is what point? That is 3, 6, right?
Yeah.
And this one is 4, 4. So rise over run, we're gonna have to go up, we're going back, so it's gonna be negative, right? This is gonna have a negative slope. So we're gonna have to go up how many?
Up 2.
Up 2, and then back how many?
Or back 1.
Back 1, so it's negative 2 over 1. So the slope of this one is negative 2. Right? So then we need to figure out where it would cross. So if we use kind of our old strategies of finding the thing, we've got y equals negative 2x plus b, right? We can plug in a point, right? Which point do you want to plug in? This one or that one? 4, 4 sounds fine. So we're going to plug in a 4 right there.
We could also just go up.
We could also count our way back up there. That's absolutely true. We get negative 8 here. Bring down the 4 equals b. And if we add 8 to both sides, we end up with b equals 12. So the equation for this one would be negative 2x plus 12. So all of that, f of x equals all of this piecewise definition, and then all of that is the answer. What other questions do we have?
For the range, the domain, I wrote it where it's like the parentheses, the negative infinity, and then like.
Yeah, like in interval notation, that's great.
You can do that.
You not only can do that, but that's what I like in Algebra too. So that's great. So like the domain, what would it? I don't know that it asked for the domain on this one, but if it did, what would be the domain of this function? Goes all the way to negative infinity, keeps on going, so negative infinity domain goes from negative infinity to positive infinity, all of it. What about the range? The range is going to be a little different on this one, right?
From
Negative infinity
to 6.
to 6, not including the 6, right?
So then use a parentheses.
That's right. So you still use a round bracket there
Why would we? Oh, I see.
because it's an open circle. All right, what other questions do we have?
Can you go over 12?
Sure. What is 12? 12 is a graph one. So let's swing the camera around. Leave the TV on in case we need it again. We'll do this on the whiteboard. I need to, now that I've got this tablet, I need to go back to the early days and get my projector back out and just project on there and just use it all the time. That'd be smart. But then we have to figure out where the projector is, and it's also hot. So I don't like that. Maybe when it's winter time. All right, so for number 12, we're going to graph the following piecewise function. F of x equals negative 3x when x is less than negative 4, or less than or equal to, and it is x if x is between 0 and negative 3. Negative 3 is, no, positive 3 is inclusive. 0 is not. And it is 8 if x is greater than 3. Okay. So piecewise functions are one of the rare things in my classes that I teach a pretty procedural step-by-step. Do this, then this, then this, right? Most of the things, it's more useful, you understand what it is, you understand how this is a tool I can use to solve this problem, whatever it is. You learn your tools and do the thing. That's more useful. However, the piecewise function, it would be easier if we just kind of like do the steps. So, what are the steps?
You graph. You start by putting the thing on the other side of the if on the thing.
Yeah, how do I put those on the thing?
You put it with a dotted line.
Yeah, I like to dot in our chunks, right? Because then we have, okay, I need to figure out what's happening here and here and here, right? So we're at negative 4, negative 1, 2, 3, 4. There's a chunk over here. So over here is a chunk. You can even label it what's going on up there, right? Then from 0 to 3, so there's a chunk where there's going to be nothing, right? Now we've got from 0 to 1, 2, 3. You know, it dawns on me that I put on this mic and we did whatever else. But then I didn't switch the camera over to the right mic. Let's fix that real quick. So that if and when somebody does need to watch this, the sound is less horrific. There we go. Let's double check to make sure it's still coming through. It is great. Now it's less horrific. If y'all need to go back and watch this, and this particular lesson might be one that y'all did want to go back and watch, because this is one that can trip people up. All right. So there's nothing here in the 0 to 3, in the negative 4 to 0. There's no definition, so there's no function there, which means that our domain is going to have kind of a different vibe a little bit, right? Okay, so let's start with the far left one. What is the slope of this line? Negative 3. What is the y-intercept of this line?
What is the y-intercept of this line? What is the b? I see you staring at me because it's not there, which means it's what?
Doesn't exist.
No, it exists somewhere. Where does it exist? What can we add to negative 3x and it doesn't change it? 0. So the y-intercept is 0. So if we were to continue this line, so down 3 over 1, so if we're going to continue this line and do the thing, it's going to come from here, right? But we don't have this to work with. So we got to figure out what it is going to be right here. So we need to find out, so we need to figure out the negative 4 intercept. How could we find that?
Multiply 3 and 4 together to get
Yeah. Yeah, so you're just substituting negative 4 in here, which is exactly what you would want to do. You get positive 12, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So our graph crosses negative 4 at 12. So it's going to have a point over here. It's a filled in dot because of this, right? Now, because of where we are, we're going to go down 3. We can't do that really. It's really actually going to be over here. We're going to have to go up 3 and back 1, right? To get negative. So up 1, 2, 3, 1, 2, 3, and back 1. I've got my thing in a mess of a position, but it's all right. We'll live with it. Okay? So there's the first chunk. There's nothing here, so he's going to be blank. So y equals x. What is his y-intercept?
X.
No. Y equals x is the equation. If I have the equation y equals x, what is the intercept? Y-intercept?
12. Oh, I mean 0.
0. What is the slope? 1. This one has the thing, right? It's an open circle because that, right? And slope is up 1 over 1. So up 1 over 1, up 1 over 1, connect the dots. Is it going to be a filled in or an open circle on this side? It's going to be filled in on the 3 side, right? So what is the last chunk going to look like?
We go to 8 for the y-intercept.
Mm-hmm. 1, 2, 3, 4, 5, 6, 7, 8 for the y-intercept. It's an open circle. Now what?
We go over and up 1.
No, that would be a slope of what? It doesn't have a slope of what?
Is that a slope of 3?
It doesn't have a slope of 3.
It's a horizontal line.
It's a horizontal line. It has a slope of 0. Because this would be y equals 8, right? That's always how these work. Y'all are looking at too many places at once. Let's take a step back. Each one of these is its own little thing, right? This is y equals negative 3, x. You know how to graph that. That's easy peasy. You start at 0. Oh, you go down 3 and over 1. Down 3 over 1. Graph it, right? Easy peasy. This one's the same thing. This one is y equals x. You know how to graph that. That's easy peasy. You start at 0. You go up 1 over 1, up 1 over 1. Connect the dots, and Bob's your uncle. This one's easy peasy. Y equals 8. Y is always equal to 8. It's a horizontal line at 8. So that's all you're doing. You're just graphing that line and that line and that line. This one just only exists over here. And this one only exists here. And this one only exists over here. So this one, we've got a straight line at 8.
Is it horizontal
Because
because there isn't an x?
there isn't an x. Right? Okay, so let's write the domain for this. What's the lowest x it can be?
Negative infinity.
Negative infinity. And then we've got a gap, so we got to represent the gap at interval, oh, what am I doing? Negative infinity to where?
To
To negative 4. Are we including the negative 4 or not? Okay, so it stops there, then we got a gap, so it's not all real numbers anymore, right? So how do we say there's more?
we do that union.
We do the union, that's right. So union with what's the next number x can be? 0, including 0 or no? Not including 0, right? It's open circle. And that there, does it ever stop?
No.
No, so there to positive infinity, right? So the range is even more silly, right? What's the lowest y value? 0, including 0 or not including 0? Not including 0. Up to where?
6.
Up to 1, 2, 3.
Oh, because there's a gap.
I guess it's 3.
Including 3?
Does it not go to infinity though?
It's going to, but there's a whole bunch of gaps because of that straight line there. Including the 3 or no?
Including it.
Including it. And then where's the next bit?
8.
8, and only 8, right? Including 8. And then where's the next bit? 12 to where? 12 to infinity.
So did we have to write all of that because we had?
Yeah, because it doesn't, because there isn't any y values in these spaces.
If that first one,
Mhm.
0, if it wasn't stuck at the line, would it be infinity? Like if it didn't go.
So if it was like from here to here or something, then yeah, it would just be 0 to infinity. Yeah, which you could do. You could definitely have that. What other questions from this lesson?
We did 22.
Sure. It's time to be 20. Step function. Which are actually, once you get the pattern, are like the easiest ones in this lesson. Once you get the pattern.
I just didn't know.
These are greatest common integer problems, which are more common in real life situations than you might think. They're any situation where you always round to this thing. Like if we're in this chunk, it's always this. And we always go to 1, or it's always 1. And then you get to the next bracket. It's kind of like, y'all know how taxes work, kind of? Like if you make between this much and this much, 15%. This much to this much, 20%, right? That's how that works.
That's how tax brackets are.
Yeah, that's how tax brackets are. Yeah, so it's that kind of thing. Where if you're in this range, then this is what you get. The function looks like that. It's got these little stair steps, right? All right, now, sometimes in real life, they don't always stair step evenly, right? Sometimes it's stair step, stair step, stair step, right? Or whatever, depending on the situation. But anything that does something like that is how this works. So the greatest common integer function, just without any piecewise or any extra definition stuff, looks like this in its equation. What does the parent function look like? Does anybody remember? Anybody look at it in the book? Where does it start? Because that's what we need to know is where is the beginning, so that then when we do a problem like number whatever you asked for, or we can know how to change the beginning, right? It does start at 0, 0. And then what does it do?
It goes to 1.
Yeah, and then it goes to 1.
And it goes up 1.
And then it goes, and it jumps up here. And it goes like that. and then it goes over here and up here, and it goes like that. That's the parent function, right? The negative, in the negative range, it would be like this.
Wouldn't the 0 be a closed circle and 1 be open?
Does it start? Does it start? Oh, yeah, it does. You're right. You're right. Yeah, I did that backwards. You're right. Yeah. Okay. So that's the parent function. That's how it starts. That's the OG, right? So on number 22, 20, right? We need to look at transformations of parent functions. The same as any other type of function. The same sorts of rules applies at plus 6, is that right? Minus 6. Okay. So same sorts of things, right? You know, when we back in Algebra 1, and did we do this in the review unit? I don't remember. When we have something like this, what am I writing? Which we're going to review a lot later. We have a few different ways we can transform things. You can multiply something, which would be a dilation, which is going to stretch it or compress it, right? We're going to do that, deal with that. But what all these are doing is moving it. They don't even do stretch or compress. And if you have a greatest integer problem on a test or something, that's all we're going to be doing there, is just moving it, not stretching it or compressing it. Okay? Just moving it. Okay? So inside the parentheses, now this doesn't really have parentheses, it has the thing, right? So if you look at like number 22, that has a change in, oh, just kidding, not just kidding, on a test, I'm not just kidding, but in the book it does have one that stretches, but we'll deal with that in a minute if we want to look at it, right? So inside the parentheses, it is left or right, that's horizontal. It also moves opposite of what you'd expect. If we look at that number, I need to go give a guy his garage door opener real quick. I'll be back. Hey, are you here? Okay. All right. I'll just come out and give it to you. Uh-huh. Bye. It don't matter. If it doesn't work, still replace the battery. That's probably going to happen. What? It's on the calendar. Your shoes match your shirt.
Thank you.
Okay. Sorry, that took longer than it meant to because I accidentally dropped it and then it popped apart. So I had to put it back together again. Okay, so inside the parentheses moves left to right and moves opposite of the way you'd expect. This one is outside the parentheses. Outside the parentheses is moving either up or down. Which direction is it going to move? Down. Easy money, right? It's going to move down how many? 6. So all you have to do to graph this sucker is take your parent function, which looks like that, and move it down 6. Right? So we're going to start out at negative 1, 2, 3, 4, 5, 6. And we're going to start our thing. And then there it is. Right? And it's going to be up here. Go over 1. Right there. And then you get a marker that works and you keep on drawing the thing and you did it. Easy peasy.
For the one in parentheses, would you do up or would you?
No, so in parentheses is left or right, and it goes opposite. So like that plus 2, you're going to move to the left 2. That 3 is also going to stretch it horizontally. So instead of being 1 long, it's going to be 3 long. Yep. These are actually, again, once you get the pattern on these, they're kind of almost easier than a lot of the other ones. You just have to kind of get the pattern.
For the, how do we do the range since we don't get through everything?
Okay, so does it ask for the domain and range or just the domain on these?
It asks for identify the domain and range.
Domain and range, okay. So the domain is easy, right? The domain is all real numbers, right? From negative infinity to positive infinity. So for the range on, if I was asking you for, to do one of these on a test, I would only ask for the domain, okay? The range you can't use interval notation. It's not possible because the interval notation assumes that it's continuous, right? So the range, technically, the way you would write it is you'd have to use set builder notation, which I don't teach until pre-calculus. But it's not that difficult, but it would look like this. It's y, right? That's the variable we're using, such that n times y, and then you would have to say n is a member of, what is the set that is positive and negative whole numbers? Integers is a member of the integers, which you would have to learn is the letter Z. That's kind of funny looking. So that's how you would write it if you were writing it correctly. Because you can't write the range in interval notation because it's not continuous throughout the whole thing. You could write, like if I asked you to do something like that, you could write the set of all integers. That is basically saying the same thing, right? What other questions from this lesson? I could. Absolute value. Number 10 is h of x equals the absolute value of x plus 4. Okay, so again, it's helpful, very helpful, if we know the parent function. So what does the absolute value parent function look like? So what does f of x equals the absolute value of x looks like? Yeah, it is a v. So it's y equals x, and then y on one side, and y equals negative x on the other side, which is why they chuck it in the same lesson as the piecewise function, because you could actually define it piecewise. All right, so it's y equals x over here, and y equals negative x over here, right? Because that's what absolute value does, right? It takes any negatives and it flips them to positive. right? So it looks like that. That's the parent function. So this is the transformation, is the change. Is it inside the parentheses or outside the parentheses? Inside, right? And it's added or subtracted, so it's just moving it. It's not stretching it or compressing it, right? It's just moving it. So it's going to take this guy and it's going to move it. What did I say about inside? Inside moves what direction? Opposite of what you'd think. So you would think +4 would be moving this way, but it's actually to the left. Okay? So to graph this guy, you're just going to take the parent function, that one, and you are going to move it to the left 4 spaces. So instead of starting at 0, 0, we're going to move back 1, 2, 3, 4. And we do the same thing. We count up 1 and over 1, and then we count up 1 and back 1, and then you connect the dots, and there he is.
For this one, I just made a T-chart.
You could, yeah, you could. You could. That is all. If the instructions are graph, you can always fall back on a T-chart. Like if you're like, I don't remember anything else, you can always at least do that, right? That's great.
How would you find the domain and range of it?
Okay, so what is the domain? What's the farthest negative? Negative infinity. What's farthest positive number? Infinity, right? It goes all the way in both directions. It's all real numbers. What about the range? What is the lowest number? 0. Including 0 or not including 0? Including 0. What's the largest y number? Infinity. It keeps on going up.
Since it's absolute value, it never gets to the negative y's, right?
Correct. Correct.
I've been overcomplicating these.
Okay.
For 8, would you move it with the slope? Would you move it up instead of down?
For number 8. So number 8 doesn't move. Number 8, actually number 8 is weird. We may want to look at number 8 because of where they shoved the negative. Because number 8, is kind of goofy. If that negative was on the outside of the absolute value, it would be a totally different story, right? Okay, so all the changes are inside the parentheses. Inside is horizontal. So it has a horizontal change. It has a horizontal stretch, right? So instead of being a 1, 1, it's going to get bigger, right? And then it's also got a negative. So if the negative was out here, it would take that V and it would flip it down, right? It would take whatever positive, make it negative. But that's not where the V is. It's negative. So like, okay, well, I'm a little bit confused now, right? Whoa, and also dying.
Don't doubt us, Mr. Strunk.
Okay, right? So, I'm a little confused. What's going on here? What would this do? So, if I were you right now, what I would do is exactly that. I'd grab me a little T-chart, and I would shove some numbers in it and see what happens. Right? So if I shove a -2 over there, g of -2, be +6, absolute value +6 is still 6, right? If I shove a 1 in there, is the absolute value of +3, which is still 3. If I shove a 0 in there, what's it going to be? 0. If I shove a 1 in there, what is it going to be? 3. If I shove a 2 in there, what is it going to be? 6. And it's +3 and +6 on those because the absolute value is going to make it positive. So because this is absolute value, because of the way it works, that negative inside doesn't do jack squat. Doesn't do anything, right? It always dies. So this is the same graph as this is going to be. All right, so then we just plot those points, easy peasy. Get a horizontal stretch happening. So normally the parent function, I'll go ahead and dot in the parent function so we can see how this did change, so we can think about it. We can understand what's happening. So normally the parent function goes up 1 over 1 and up 1 back 1, and it dots in here like this. Or it doesn't dot in there, but this is the parent function. This one. Right. That's how it normally looks. So what about hours? How does it change? Right? It goes over 1 up 3 this time. 1, 2, 3. And it goes over 2 up 6. 2, 3, 4, 5, 4, 5, 6. And then they'll be mirrored over here, right? Time for me to get some new colored markers. These are all giving it up. Wonder if I have some more in the cabinet. That'd be nice. All right? So same thing, it's just horizontally compressed. Which again, I said inside is opposite, right? You'd think if there was a 3, it would be horizontally stretched, but inside opposite, right?
So since it wasn't in front of it, it just changed the slope of it. So like
In this particular problem, this particular problem is even crazier. Like if we were to, because if we were to graph, say, an h of x equals 3 times the absolute value of x, it's going to look the same. It's going to look not any different. You can plug in points and prove the same thing. Well, not prove it, but evidence it, right? This problem is wild. What other questions do we have from this lesson? Number 30. Giving. Patrick is donating money and volunteering his time, so nice, Patrick, to an organization that restores homes for the needy. His employer will match his monetary donations up to $100,000. No, that would be crazy. Up to $100. Identify the type of function that models the total amount of money received by charity, and Patrick donates X dollars. Okay, so the answer to this was a piecewise function. Let's talk about why it was a piecewise function. What is a piecewise function? Conceptually, what is it? Well, we can represent it with a graph. We can represent pretty much any function with a graph. But what makes a piecewise function a piecewise function?
There's multiple lines and stuff.
Yeah, so there's multiple different things. So if this condition is true, then this is the definition. But if this condition is true, then that's. So he's going to match it up to 100,000. I keep saying 100,000. Up to $100, and then it changes, right? Then it's different than what it was before. So that's why 30A is piecewise. Then we're going to write and graph a function for the situation. So Patrick is making money and volunteering his time to an organization that restores home for the needy. His employees will match monetary donations up to $100. Okay. Trying to think of how to explain what's going to happen here. So, what are the chunks? Let's start with that. Let's kind of see if we can get a bit of a graph type thing happening. What are the axes? Let's start by labeling that. What are we actually graphing? Okay, so both axes are money, kind of, right? What is this money? What is the independent variable in this situation? Yeah, so how much money Patrick gives in. So money Pat gives. Right? That's the x-axis. What is the y-axis?
The employer, how much he'll match.
So this is tricky. This is why I paused for a minute, and I think we're headed in an okay direction. So that is a variable that's going to change the definition. But that isn't the other axis. The other axis is how much money is actually given to the charity, right? So that's how much money he puts in is affecting how much money is going to be given to the charity, right? Okay. Okay. So in the first chunk of time, oh, what are our, before we do that, what are the chunks? When does it change? Whenever he gives $100. So at some point, there's $100. That is our first chunk, our only chunk. That's the only time the situation changes. Right? Okay. So, how does the slope of this one compare to the slope of this one? What is the employer doing? He's doubling it. So it's 2 times the original. Whatever the original is, we don't even have to know that. Right? We're just doing the relative relationship, right? So this one, the slope is going to be 2 to 1. So up 1, 2 over 1. Up 1, 2 over 1. All right? So all the way up there, it's getting doubled. What is the slope after $100? 1. It's just 1. So up 1 over 1. So up just 1 from here over 1. Up 1 over 1. And so it's going to, I probably should have made my things narrower to be able to see it better. But it's going to drop to a 1-to-1 slope. So there's the picture, right? Sometimes it can be easier on a word problem like this to get it's kind of like we've said since Algebra 1 or even pre-algebra, if a problem describes a picture and it doesn't give you a picture, draw the picture, and then your brain can figure out what in the world is happening, right? So how many pieces are in our piecewise function?
2.
There's 2. So what is the first piece? 2x, yeah. But that's not even, I was actually asking for the range part of it.
If x is less than or equal to 100.
So close, but there's something you're missing.
X is greater than or equal to?
No, that's the other one. Is he going to ever give negative money? Is he stealing from the charity? No. So between 0 and 100 is 2x. What is the equation going to be on the second chunk? Just x. Whatever he gives is whatever he gives. And then what's the thing here?
X is greater than 100.
Greater than 100. Makes sense? What other questions do we have from this lesson? Sure. We are graphing the piecewise function g of x equals 2x plus 2 if x is less than -6 and x if it's between -6 and 2 inclusive, and it's -3 if x is greater than 2. Okay. What should we do?
Graph it. I guess find the y-intercept.
Gonna put our chunks on here, right? But if you're confused, probably doodling isn't the next best thing. Maybe engaging with the thing and asking questions if you have them would probably be more beneficial, don't you think? So 2x plus 2 over here, and between here and positive 2, the definition is x and over here it's -3. Let's start with the -3 one. That one's easy, right? What is that going to look like?
It's down 3 and over 1.
No, it doesn't have a slope of -3. It doesn't have a slope other than 0, right?
This starts at -3.
This one is the one.
Oh,
It's just a horizontal line at -3.
It's just a horizontal line at -3. It's going to be an open circle, right? Why is it an open circle?
It's not equal.
Yeah, because it's not equal to. What about the middle chunk? That's the next easiest. Let's go ahead and grab that one.
The slope's 1.
The slope is 1. What's the y-intercept?
0.
0. So we're going to put a dot at 0. And then go up 1 over 1. Put another dot. Going to connect those dots. Put a line there. With open circles, closed circles, or one of each?
Closed.
Closed on both. Those are both equal to, right? All right, now for the tricksy one. Because we don't have the y-axis, and it's not just a constant function. It's the word I'm trying to say.
Can we just graph it and erase the part that doesn't meet?
You could. So that would be it. So you could just graph, go up 2 and then count up 2 over 1 and then erase all the chunk over here. Sure, you could do that.
Don't you just plug in the x?
We do. So what we want to know, so normally we're looking for the y-intercept. What we want is the -6 intercept, right? Because we want to know where it exists here, right? So we're going to put a -6 right where x is. What's 2 times -6?
-12.
-12. What's -12 plus 2?
-10.
-10. So we're going to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we're going to put a open circle. The slope, we would normally count up 2 over 2, right? All right, but we don't have anything over there, so we're going to count down 2, back 1. We're going to reverse them both. So down 1, 2, over 1. And we're going to put a dot. Then we're going to connect those dots. What would the domain of this function be? All real numbers. Because we go all the way to the left, all the way to the right. There's no gaps because this covers the gaps. So the domain is negative infinity to positive infinity.
Are the same thing?
Well, let's take a look. Does it ever stop going down? No. So negative infinity. Does it ever stop going up?
Yes.
Yeah, where?
At 2.
2 is, yeah, but it stops somewhere else sooner.
It stops at negative.
Yeah, there's a gap right here where it doesn't exist at all, right? So what is this? What is the y value of this one? Negative 10, right? So it goes to negative 10. Is it including negative 10 or not including negative 10? Not including negative 10. Then we union, right? Where does it pick back up again? Negative, not negative 6, I don't think. Oh yeah, it is negative 6. You're right, because that has a slope of 1. Yes, that's true. Negative 6. Except that's including negative 6, right? Negative 6 all the way up to where?
Positive 2.
Positive 2.
With a bracket.
Easy peasy. All right, kids. We will see you on a Tuesday, whatever the next class is. Y'all know what's happening.
Tuesday.
The test wouldn't be till Thursday. We have 2 more lessons. Yeah, we have, because we have parent functions and transformations, and then we have graphing linear and absolute value inequalities.
And then we're done with this lesson.
This unit. And then we take a test on Thursday.
Well, you know what I mean. This like sesh.
It's not lit. It doesn't show the next lesson, the other lessons. I'll look at that right now.
And when you go to lesson 3.
Thank you. Thank you.
I just have an LED.
Well, that tracks.
I'm like,
Oosh.
my classes are merging together.
More ways than one, probably.